Hello, welcome to Unit 4, Lesson 3 with Professor Blackman. In this lesson, we'll be talking about factoring. And we're going to start out by looking at the greatest common factor and then look at factoring by grouping when we have four terms. So a little bit of vocab. A factor is when you have products of multiplication. So for a polynomial, a lot of times that's a binomial. Sometimes it's a monomial and a binomial, but a lot of times it's two binomials. And so the process of finding factors is something we call factorization. So right here, we're going to start out with the GCF, so the greatest common factor. So we're trying to look at what are the factors. So if I take 6a squared and I break that down, that has the factors 2 times 3, which is 2 times 3 is 6, times a times a. And if I take 3a and break it down, it is 3 and a. So as you see, when we're looking at for a greatest common factor, we're going to look at the common factors that they have in. So like 3 and 3 are common factors. But A and A are also common factors. So 3A is the greatest common factor. So what we're going to do is we're going to take 3A and factor that out. And inside, what is left? Well, 3A times what gives you 6A squared? So that's 2A. And 3a and a 1 give you that 3a. And because we are factoring, the opposite of factoring is multiplication. So we can check by multiplying. And 3a times 2a plus 1, if I distribute that, I get 3a times 2a, which is 6a squared, and 3a times 1 is 3a. So you can check always your factoring by using multiplication to check. All right, let's go ahead and look at another example. All right, so 4 and 12, the greatest common factor that you can pull out of both those numbers is a 4. X squared and x, so that's xx and x. So x is the biggest variable that we can pull out of both. Y and y squared. Well, y, and this is y, so y is the biggest that can be pulled out. So when a 4 is pulled out, you're left with a 1. When an x is pulled out of the x squared, you have an x left over. Y is pulled out completely. Bring down your sign. You pull a 4 out of 12, you're left with 3. X pulls out completely. And when you pull that y out of the y squared, you're left with a y. And again, you can check that. 4xy times x is 4x squared y, and 4xy times a negative 3y gives you 12xy squared. So this is correct, and we can always check that using multiplication. Let's look at some more examples. So in this one, we're going to look at what we can pull out. Well, 3, 3, and 9. So 9 is 3 times 3, so we can factor out a 3. Then let's look at the variables, y squared, y, but there's no y in this third term, so we can't pull that out. So 3 is the greatest common factor that's found in these three terms. When you pull out a 3, a y squared is left. When you pull out a 3, a minus y is left. And when you pull out a 3, we have a negative 3 that is left. And we can check that by using multiplication. Multiply by 3, you get the first term. Multiply by 3, you get the second term. 3 times 3 gives you 9, which is the last term. All right, so let's look at our fourth example here. 4, 6, and 12. Well, 4 is found in 4 and 12, but it's not in 6. But they're all even numbers, so we can pull out a 2. A, and A is found in each one. B is only found the first one, and so that's all that we can pull out is just that 2A. What's left is 2B minus a 3C plus a 6D. And so 2 times 2 gives you the 4, 2 times negative 3 gives you the negative 6, 2 times 6 gives you the 12, AB gives you AB, AC gives you the AC, and AD gives you the AD. So this multiplied out does give us our original term. Let's look at another example. So in here, we're going to find the GCF, but if you notice, all of our leading terms are negative. So when your leading term is negative, you factor that negative out with it. So I'm going to put a negative here because my leading term is negative. And then 3 and 18 both have a 3. T and no T's are left in the other. So that negative 3 is what I can factor out the most. And when I factor out that -3, the t is left. And 3 pulled out of 18 gives you a 6. But since I pulled out a negative out of that positive, I need a negative here. And we're going to go ahead and check this one. Because remember, we can always check using multiplication. -3 times t minus 6. And so when we use a distributive property to check, -3t, negative times negative is positive 18. Pay very careful to your signs when you are factoring out a negative. So here we're going to factor out the negative again. A to the fourth, a to the third, a squared. That's a, 4 a's there, 3 a's here, 2 a's here. So the a squared is the greatest a that we can factor out, leaving an a squared. And since I factored out that negative, this is now positive. This next one's positive. So if you factor out a negative, it will change it to positive, leaving a 2a. And then you factor out the negative, so the sign would change, and that's positive 5. And again, you can always check this using multiplication. Let's look at some more examples. So with factoring by grouping, we're going to look at terms that they have in common and pull them all out. So here you can see that this x minus 3 is here, and this x minus 3 is here. So we're going to pull out that entire x minus 3. And when we do that, what is left is the a that is in front and the plus 2 that is in front of the other one. And we can always check. And so if you have x minus 3 and a plus 2, if you multiply the x times everything, you get a x minus 3 times a. And then x minus 3 times the second term would give you 2 times x minus 3. All right, so again, x plus 4 is found in both. So we're going to factor out that x plus 4. And what's in front of the first one is an x. And what's in front of the second one is the minus 5. All right, let's look at some more examples. So here with factoring by grouping, we have 4 terms. So just similar, we're going to get it to what we just had in the previous slide. And we're going to look at this grouping first. And then we'll look at this grouping. And so in our first 2 terms, they have a y to the 7th in common. And when you factor out that y to the 7th, it leaves a y minus 7. And if you notice, what follows is a y minus 7, but the only thing they have in common is a 1. So I'm going to factor out a 1 and y minus 7. If you do factor by grouping correctly, the binomials that are formed are the 2 binomials that will always be the same. So now we can, just like on the previous slide, pull that y minus 7 to the front. And what's left is a y to the 7th plus 1. And just like all examples before, because it's factoring, we can check using multiplication. And so in order to check that, we just write it again. Y to the 7th plus 1. And distribute, you get y to the 8th plus y minus 7y to the 7th minus 7. And if you look, that's the first term, that's the third term, that's the second term, and that's the fourth term. Not in the same order, but because we know that we can switch the 2 middles, and it's addition, subtraction, so we can change the order and it's exactly the same. All right, let's look at another one. So look at your first 2 groupings, and we'll look at our last ones. All right, so we get x squared. When you factor out an x squared, you're left with x plus 8. So we're looking to get that x plus 8. If you notice, both signs are negative, so that leading term is negative, which will factor out. And I'm going to factor out a 5, because I know that there are multiples of 5. If I factor out that -5, I'm left with x. You pull a -5 out of a -40, you get plus 8. So x plus 8 is found in both. And what's left is x squared minus 5. All right, let's look at our last slide of examples. Same thing, just a little bit bigger numbers. So with these bigger numbers, I'm going to see if they have anything in common. And I can see that they are multiples of 12. So I'm going to make this problem simpler by factoring out that GCF first. So by pulling that 12 out, I now have 2x to the third plus 6x minus 3x squared minus 9. And so now when I do our factoring by grouping, I'm going to look here and I'm going to look here. I'm going to keep that 12 just out in front and do it just like I did on previous slides. So factor out a 2x and you're left with x squared plus 3. Factor out a negative 3, leading term's negative, and I get x squared plus 3. And so now I can put that 12 out in front, and I'm going to shift my two binomials that are the same to the x squared plus 3. And then I'm going to put my 2x minus 3 right there. And again, you can always check using multiplication. Here I've got some big numbers, but these is 2, and this is a multiple of 2, but these two are not. So there's not a GCF I can factor out. So I'm going to start with the 2y squared. After I pull that out, I get a y squared plus 3. Now I need a y squared plus 3 here, and I see that the leading term is negative, so I'm going to factor out that negative and a 5. And when I do that, I'm left with y squared plus 3. So you're always looking to make those binomials match up, which we'll then put out in front. And then I'm going to put that 2y squared minus 5, which were the two that were in front of the binomials that matched. That is all I have for you today. Happy studying.